Welcome back, everybody. You got Will and I-Man here from the Block Runner MetaZone, Rovi and Mscribe, and today we got some DMT sauce, some juice, and some to eat.
What are we eating?
I don't know.
I'm fucking hungry. So are you, I guess.
Yeah, yeah.
So we're thinking about food. But we're also thinking about block drops, dude.
Yeah, we're going to be eating some block drops.
But maybe we can get to that in this video, maybe not. But really, we need to address some things, right? Some very core critical things. DMT is obviously happening, right? You go to Mscribe, you see like these new projects are proliferating at lightning pace, right?
Yes.
Crazy. Like PvP going, like
it's mayhem.
Yeah, there's PvP activity happening on Mscribe. People are competing for these blocks. New digital matters being issued and generated, whatever, right? So DMT is in full motion, but we're hearing through the grapevine that there's still a little bit of confusion, and that's mostly probably our fault at the end of the day. Anytime there's like any kind of misunderstanding or confusion, we take it as we haven't done a good enough job explaining this stuff, right? It's not your fault. It's our fault, right?
Always point the finger at yourself.
Correct, right? We're taking the Tom Brady approach. Right?
Yes.
He's like, you know what? If we fail, I'm the quarterback, right?
Yeah.
It's not my lineman who's like slow as fuck. You know, that's not the reason why I got sacked. Actually, you know, he is
kind of is. He sucks.
Yeah. But nonetheless, so we're taking the quarterback approach. So we need to do a better job at explaining as granular as it takes, right? So people understand, like, how are these creations being manifested? Because some people are saying it's off-chain, just like every other NFT.
Yep.
It's probably stored in IPFS. Where are the scripts, actually? I hear all this stuff about scripts, but I look at the JSON, I don't see any scripts there.
Right.
Like, so we need to kind of break that down, dude.
Yeah. Okay, we'll cover that at the end. But let's talk about this first. Block drops. This can get very interesting what creators end up doing with block drops, we say. And then here's Tick a Bit. It says, imagine the roles being displayed in the center of the watch face and NAT diamonds on the numbers. Yeah. That was from us in our video. It says this could be interesting. And then here's like some prototype examples.
Yeah. Very cool.
And so Tick a Bit is the one who designed these watch faces. And then obviously the creators, King, we have Evie, and Frogs.
The NAT Frogs.
NAT Frogs. Right.
Yeah. So these are already existing deployed UNATs, right? Tick a Bits is not an existing deployed. Well, maybe the ticker is actually deployed, but the on-chain renderings have not, right? So
correct.
Which
is on purpose. It's a reveal. It's a strategy, marketing strategy, all that stuff.
Yeah, all that stuff. But nonetheless, so we're this brainstorming, I guess, collectively of like how can we leverage existing creations and now like make them part of these new creations. How do you actually distribute that through some sort of mechanism, right? And it has brought up the term block drop, which we haven't really talked about in a while.
That's right.
Originally was like targeted more towards for Bitmap, right? Which it still is. If you go into the Git book, the only time we really mention or talk about block dropping is through the third method of non-arbitrary token distribution, right? Which is the provenance model, right? So
that's right.
Yeah, there is bitmaps can be pointed to, and you could distribute assets directly to a bitmap, right? So
yeah,
you could do that now with any non-arbitrary asset, right?
Yeah.
Well, not now.
Yeah.
But we have confirmation that
it's coming.
It's coming. Yeah.
All right. Continuing on, everyone that is impressed by RSIC pre-rune token distribution mechanism, wait till you realize bitmaps have the mechanic built in through the utilization of NATs and parent-child provenance.
Yeah, that was me, dude. So I said this back in January because that's exactly what we just described. There's like a tremendous market opportunity. I think a lot of people don't realize once this technology actually exists.
I'm gonna retweet your 6-month-old tweet, dude.
Thanks, dude. Well, yeah, that's the whole point of making this video. Let's bring it back up, right? Because we're getting close, right, to this actually happening.
Yes.
Right, across the board.
All right. Another. Oh, okay. So you referenced. So what's going on here? Interesting question. Can meme coins be created from a bitmap?
Yeah. So here's a conversation. I like this Dev9 take here. Let's just go through it real quick.
So a meme rune can be created by whitelisting all the addresses that hold bitmap and having a claim by each address. That's a way, but the kind of resembles BMP, which is a BRC20, only with runes. What if it were straight out of Bitmap's DMT? What could that look like? Maybe a specific word pattern found in parcels hash would create sort of an Easter egg hunt. And And then bitmap parcels in hand bring up interesting questions in regards to extracting and inscribing bitmap DMT. So yeah, so then you point out that there's a link in the DMT Git book that goes over block drops for bitmaps.
Yeah, I think it's so it's just to kind of let's refocus on DMT has direct application for Bitmap, right?
Yeah.
So it's a big deal. People want to know and understand, like, how can we actually do this? How can we leverage the data of a Bitmap to generate new tokens, new assets, whatever? So here it is. BMT is the method to do exactly that. Doesn't have to be such a non-interesting ticker as BMT.
Yeah.
Right? It
could be significantly longer, up to 32 characters if you want.
Yeah, according to Tap Token Protocol token parameters, right? So yeah, you can call it, I don't know. I guess I made a meme in the past. What was it? 9 to 5 guy, yay or something?
Yeah, 9 to 5, my guy.
Yeah, somebody made that rune.
Wasn't us.
Definitely wasn't us, because we talked about, the curse of living, right? Where it's like, you got to go to work.
Yeah.
You got to eat your
peanut butter and jelly.
Your peanut butter and jelly just to get through the day, right? So it's like meme tokens is our saving grace, right? That's the theme. I'm sure you guys could do a way better job than me at making something funny.
I was inspired, dude.
Only partially, though.
Yeah.
I mean,
I didn't actually.
You're not gonna. Yeah, you didn't buy
the token. Yeah.
You definitely were not inspired then.
Yeah.
So Bitmap community, guess what? You're right. This is a good thing to ponder about and think. How can we leverage the data sets within our bitmaps,
right,
to produce this new value, right? In the form of meme coins, in the form of UNATs, you name it, right?
Mm-hmm.
This is on the horizon.
Yeah. All right, moving on. So why block drops? Why not airdrops, man?
I don't know. You tell me.
It says 41% of the top ZK Sync token airdrop recipients sold full allocation. And so people are sort of unhappy with that.
Yeah.
People airdropping or farmers are basically letting go of their tokens.
Which I think we predicted would happen like years ago. We talked about ZK Sync literally 2 years ago.
Yep.
And we we knew an airdrop was on the horizon. They were putting out all the typical details, right? Here's a test net. Fish around in there. Most likely, your activity is going to be some qualification for a future airdrop. We didn't know it was going to take 2 years to actually fulfill it. But it's like, obviously you put out the messaging that you just need to interact with this stuff, and you're going to get farmers, people who are like not genuinely engaged with your ecosystem. They're just trying to extract what they can.
Right.
This is the result of that. And this is happening and being applied across all of Web3, right? Airdrops.
Yeah.
And so it's like, let's have a discussion. Is this like the most optimal like ecosystem growth tactic? I guess there's some merit to it, right? It gets things started, I guess.
Yeah, because they push out their test net. They say interact with it.
Yeah.
Because, it's a test net. And they get a bunch of people testing it.
That's good, right?
That is good.
It's good for like the developers. Now they can actually like, see what's going to happen.
Yeah. And
hopefully it translates well for mainnet.
Yeah, the tester's return on investment is once they get that airdrop, they just like let it go.
Just dump it, right? So I don't know. It's interesting to explore. So, I mean, we're introducing a new avenue of block drops. So to your mind, what is your elevator pitch? Why are block drops like
Well, block drops are very specifically in the sort of ethos of Bitcoin. We know that Bitcoin is going to last for a very long time, right?
Yeah.
It's going to last beyond our lifetimes.
For sure.
Right. And so we need mechanisms that also persist beyond our lifetimes.
So what's wrong with airdrops?
Airdrops require a centralized entity, whether it's humans, a system, a server, whatever, to collect a bunch of addresses and actually do an airdrop. Whether you claim it or you actually issue those tokens, it's a one-time event in history. An airdrop occurs.
Okay.
One time.
Yeah.
A block drop is persistent.
Yeah.
Meaning if somebody mints a bitmap into 100 years from now, they'll mint it, right? They'll mint it, and then they can inscribe the block drop from that bitmap, whether we exist or not.
Yeah, you say block drop as singular, but by then there's probably going to be like a tremendous
thousands,
tremendous access to
hundreds of thousands of block drops.
Yeah, so what becomes the value of a bitmap or any asset that has like attributed block drops to it, right? So that is, so you're right. I mean, we could be dead, and because all that is on chain.
That's right.
the decentralized network of indexers that are supporting this, aka Trac.
Mm-hmm.
We're going to be able to execute on the delivery process or how you can actually extract what it is you rightfully own as that that owner of that parent asset, right? So we're getting close, dude. I mean, I remember we talked about this, like 6 months or so ago. It got a lot of people interested. I think you give us like a time horizon. What do you think? Like, what's a rough estimation?
Yeah, so Benny, Trac, they have to do a few more things, and we got to do a few more things. So it's going to take a few more weeks, but I mean, we're getting closer and closer. And as long as things aren't catching on fire, then we should be on track for a couple of weeks.
So what's the call to action, you think, for people? Because we had a Twitter space with the Bitmap Emporium guys, and we kind of talked about this. From my point of view, it's a high priority item for us. I kind of like activate this because it has, application across the entire DMT space.
Yeah. So there's a couple of ways that you could do a block drop where you issue a block drop without privilege authority, and then anyone can mint a child inscription of that block drop on any platform forever. Or you could do it via privilege auth, where the creator creates some asset and points to an authority like mscribe, and then you would have to go to mscribe to inscribe that block drop.
Okay.
And then the creator generates some income, and so this is a pretty sustainable mechanism for creators to deploy block drops to Bitmap holders, to DMT deployers, collections, things like that.
Interesting. Okay, so keep an eye out for that, guys. And over the next coming weeks, we're definitely gonna, I guess, unveil more details once things are a little bit more ironed out.
Yeah.
Because we want to see a lot of participation for this, specifically for Bitmap, right? Because I want to see what people can come up with. So start thinking about like what pieces of content make sense, I guess, that become deployable or part of the ecosystem of Bitmap, whatever, right?
Yeah.
And like we just saw with the Ticketbit thing, you can leverage existing UNATs to amplify a new one, a new creation, right? So this is pretty cool.
Yeah, this is very cool. Yeah. This is exactly what I had in mind when we talked about it in the last video.
Yeah. Yeah, so some 3D modeler can come by. It's like, hey, I see you guys have this really cool, highly functional, very dynamic, interface display for block time, right? AKA this Rolex on Bitcoin, the first watch ever made by Bitcoin. That's what Ticketbits represents. So why, I created a 3D version of this. Let me block drop it to you, Ticketbit owners, and then now, like through recursion, I can actually display these things on my 3D model.
That's right.
And guess what? It's compatible with some whatever inscribe.space, Bitmap OS, whatever. You can actually wield this thing. You're gonna have it on your wrist.
Sure.
Right?
Yeah.
People are gonna see it, and they're gonna see, damn, like it's one hell of a flex.
That's OG.
Something.
Yeah.
I don't know exactly what they'll say, but I feel like I want to walk around with a watch.
Yeah, hell yeah.
In my metaverse space, But obviously, that's a very highly technical initiative to pull off, but nonetheless, worth pursuit.
Yeah. So, all right. We were watching this video, and there is some confusion around how DMT assets are stored on chain, rendered on chain, how all that works. So let's give some context. Watching the Ordinals Revolution podcast, just go through one of the questions from Superfan here.
Non-arbitrary tokens in DMT, digital matter theory, is also interesting because every new block means possible patterns into the future. I'm basing storyline on block data, which will keep changing to the last block minted after I'm gone. That's wild. That's why I do love the concept of it, right? Because you kind of let it have a life of its own, like its own, narrative. It kind of creates its own path, right? So awesome, Superfan. I can't wait till your stuff is released to the public and stuff. I think you're gonna have some amazing stuff with Bitcoin Heroes and how that plays out. Guys, check out Superfan's project, Bitcoin Heroes, on Twitter. He's definitely building some amazing things there. Ishitoshi follows up and says, I like the non-arbitrary data with DMT, but some of the image pointers are not fully on chain, someone said. I'm still not fully understanding this. I really like the non-arbitrary nature of generation. Yeah, so I remember a lot of people would come out and say that NatCats weren't fully on chain. But then that changed. So is it because they were put fully on chain later? That's where
there was something where the images weren't on chain, and then it had like an image thing, but not on chain. But now they are. They were kind of like bitmaps in the beginning. They were just bitmaps. The images are not on chain; they're off chain, but it's just on chain is the number, and I think that's how that was as well. I think it was just like the data, and now they are. So I'm not sure what changed with that or how they did it, but it's different now. So
maybe they recursively inscribe the images. Right. That's what I would think is like, because we know with DMT, it literally is like JSON text format or whatever, language they're using. And so the only thing I can think of is inscribing recursively or, attaching it to, to that. I don't know, our parent child, maybe, right? That could work. Right. If you inscribe the image.
I think we can step in here now.
Yeah.
It's like, so yeah, it is. It's so we've seen this like for a while now. People not really understanding how things are being rendered. It's like, during the early NatCats drop, on Magic Eden, it said it was off chain.
Mm-hmm.
Through like some internal discussions with their team, like they finally realized like how these things are being rendered on chain, but there hasn't been like a really well documented like understanding of what's being done. Right?
Mm-hmm.
If you're a developer, it makes sense, right?
Yeah.
So how can you like enlighten us, dude?
Yeah, so I thought it would be good to kind of go through an example that you guys could also walk through with us.
Mm-hmm.
And so, like you were saying earlier, we need to do a better job of explaining how all this stuff works.
Mm-hmm.
So at the very beginning, when DMT occurred with NatCats, NatCats front ran this whole thing, right? UNATs.
Yeah, EV
right?
specifically.
So he created a website. He created a way to see your NatCats. And
entering block heights.
Entering block heights, and just a way to represent the NatCat. So that way you see what you're getting whenever you're minting this JSON.
Correct.
Right. And so it's up to the creator to decide how they want to like reveal and stuff. And that was just the one method that he used just because the framework wasn't there.
Yeah.
So the way that DMT works is that, or UNAT specifically works, is that there's three assets. There's a deployment of a ticker like NatCats, which I'll show you what that looks like. Then there is a script that represents the art, right? And then there's a mint inscription. So those are the only three things that occur in a DMT sort of environment.
Okay.
So the way that you do that is go to mscribe and then hit over to the Nats page, and then let's do an example. Let's start with the Royals. Okay, so go ahead and search for the Royals here. And what you're doing here is you're sort of locating the deployment inscription.
Okay.
Right. This is how you start a DMT asset. It's like if anyone wanted to do like their own UNAT, you start with a deployment. Okay. Right. Yeah. So what does a deployment look like? So you go to mscribe, you click on the deployment ID, and it takes you to ordinals.com, and it's very hard to see. So if you can't see that, you go to content, and it's a little bit better, but this is what a JSON looks like without any spaces, all in a single line. There's the Royals.
Mm-hmm.
Data type is hex.
Mm-hmm.
Privilege authority, inscription ID, which is mscribe. And then over here before that, element. This is the element inscription ID. And so now if we go back here, it's like, okay, so there's no obvious place here that I can see where there's art, right?
Yeah.
Right? So the way that they do it is any artist, they deploy the inscription ID, the actual ticker, the Royals.
Mm-hmm.
They do it without art because they want to reveal it later.
Yeah.
Right. And so, okay, now I've done the mint and I want to show people the art. So how do I actually put this all together on chain?
Mm-hmm.
So what happens is a re-inscription occurs. Right. And so to see that, you need to go and click on the SAT number. This is the SAT ID.
Mm-hmm.
And as you can see, this Satoshi here with an ID, ordinals, right? This is the ordinal theory. Ordinal theory gives each Satoshi an ID, right? And now there's multiple inscriptions on the same Satoshi, right? This is what it looks like to do a re-inscription.
Yeah.
You're using the same Satoshi to add a new inscription ID. So if you click on the latest one, which is the third one here, you have the same JSON, right? Here's the DMT deploy. There's the element. There's the royals. There's the hexadecimal data type. There's the privilege authority. And what do you know? A new line, inscription ID.
Yeah.
All right. So now we have the deployment. Now we have the inscription ID. And so let's grab the inscription ID. So click on content and double click on the inscription ID.
Okay.
And then go to OrdiScan and then type in that inscription ID. And then this should bring up the code.
Okay.
There it is. Code being rendered on chain, right? So view the source code. And so here's what you do. Copy and paste. And this is just an example of what websites are doing, right?
Yeah.
They're taking this information.
Yeah.
And let's go to recursivebuilder.io. Shout out to Recursive Builder.
Yeah.
And this site, all it does is it renders code. Every website out there, all it's doing is rendering HTML code.
Correct.
Right? These aren't images. These are renderings, right?
Yeah.
And so what you do is you highlight this stuff here and then you paste it. And then there it is.
Change
right?
something.
Now you can just like click through this.
Yeah.
Like 100,000, and that's what 100,000
Okay.
the rows looks like. I'm not done, right? So I'm gonna take my wallet address. I'm gonna go to OrdiScan, and I'm gonna find my own royal, right? So this is what mscribe does, right? So I'm gonna scroll down. Here's the royals. Here's an inscription ID, right? And so what we're gonna do is we're gonna take this number here. Remember that number 449579.
449579.
And then I'm going to look into the code here. I'm going to zoom in and I'm going to look for this part that says mint inscription ID. I'm going to replace that.
Okay.
Right? I'm just going to let me zoom out. I'm going to copy and paste.
All right.
And that's my royal.
Damn, dude, you got a Texan royal.
So how do I prove that that's my that's a Texan, right?
How appropriate.
Right, so I'm going to go to my inventory, and then I'm going to go to UNATs. And once it loads, it should show you, I have a bunch of stuff here, and then we'll find my royal with a hat.
Yeah.
But ultimately, but that's how it works. You get a mint inscription ID, you put it into the code, and it renders. It's all on chain. This whole thing happens on Bitcoin.
So how is that code like making...
There it is. That's my guy.
That is your guy.
449579.
That is the right number.
It's being rendered in real time. This is not. This used to be a JSON. Now it's a picture because the website is saying, oh, this JSON points back to the deployment. The deployment points back to the art. So I'm just going to say, take the JSON inscription ID, take the art, put the inscription ID in the script, and then all of a sudden I have my art.
Yeah, and there's like a validation check before all this happens, right? It has to be a valid inscription first of all, which is where the TAP protocol becomes so essential overall, because anybody can inscribe this information and try and like duplicate what's happening here.
And so let's go in reverse. We went sort of like forward in the timeline. Now as a minter, how do I actually go back and like verify all this stuff is on chain? So what you're looking at here is my royals mint, this block number 449579. And here's all the JSON data, right? All this stuff down here is all the privilege authorization stuff. You don't need to pay attention to this stuff. This is like the signature, right? But we have this line right here called the deployment, right? So let's search for this. And let's pull up a new OrdiScan. And let's search for that inscription ID. This is the royals deploy. So now we're back to the beginning, right? And so because this is on this SAT number, if you click on this SAT, it'll show you these different inscriptions here, right? And so the one that you're looking for is the latest one. And then now this has the inscription ID.
Okay.
Right? And so then you click on this and back to the script.
The script.
Yeah.
But I think there's still a fundamental understanding. Probably, it's like, how is script generating like images? Like, how is this not, how are there not like links within the script itself pulling whatever the components of this final rendering of the image is? How does it do that, dude? It's kind of like explaining the wizardry of programming in itself, right?
Yeah, it is.
Yeah.
So in programming, you can draw with code squares and triangles and circles. And so you can use programming to actually draw images.
Right.
You don't need images to make images.
You don't.
Right.
I mean, you can. That is one way you could do it.
That's called recursive
yeah.
images, right, on Bitcoin.
Which there are demonstrations of that also within DMT, right? Which still qualifies. That's all on chain.
Yeah, that's right.
It's just a different process. So how does this actually make things more efficient, and like how does it scale?
Yeah,
as from a creator standpoint, like, you know,
well,
what are the limitations of this?
Well, look at this. We were just talking about how this picture was just rendered, right? Well, typically, if I were to inscribe this picture, this has infinite resolution, right? I can blow this up to infinite resolution, and that's the whole point of this, like, code art. Has infinite resolution, kind of like an SVG has infinite resolution. So, but if you were to inscribe this directly onto Bitcoin, this would probably cost anywhere between $100, $150, just because this has like larger byte size, right? Because it's an image. But in order to inscribe this JSON, it only costs 291 bytes. It's like a few dollars at best.
Yeah.
So it is extremely efficient.
What about the script itself? That was a lot of text.
Yeah.
We were scrolling for a while.
Yeah. So let's go to the mint inscription.
Anytime I see like a wall of code, I instantly think of the Matrix. It's kind of befuddling when you like witness this stuff. If you're not a programmer yourself.
Yeah, look at that.
36 kilobytes.
36,000 bytes, right? We were looking at a mint inscription of 200, what is it? Yeah, 400 bytes. Yeah, 400 bytes. And then the art itself was 36,000 bytes.
Okay.
Right? And so this costs maybe about $300 or $400 for the creator to upload to Bitcoin.
Which is still a lot better than individually inscribing. All of those
if you look at
images.
Bitmap Emporium, he inscribed all the images to himself as child inscriptions of a bitmap. He spent about a Bitcoin to inscribe all those assets to himself.
Correct.
Right? No one has 50 grand, 70 grand to inscribe images to themselves in the hopes that you can list them on a marketplace and sell them all.
Yeah. It is quite the barrier to entry, and it's going to reduce, I guess, the market penetration capacity of like creators, right? You know, a lot of these people are like starving artists, literally.
Yeah.
But they still want their creations to exist on Bitcoin, right? So as complex and complicated as this may look at face value, especially to somebody who doesn't understand like programming and how all this actually executes in code, it seems like it would result in like a very inefficient process.
No, it's
actually the direct opposite of that.
Yeah, this is the most efficient. As a matter of fact, this is how all websites work.
Yeah.
All your website is doing is rendering code.
Yeah.
It's not pulling up images. I mean, those images are stored like on servers, and some websites are pulling images in real time, but it's still rendering code. That's what a website is. Yeah. So yeah, this is the same thing.
Okay. All right. Well, that was a very interesting breakdown, dude. Yeah. Hopefully that helps some people understand. So yeah, we get it. There is some the learning curve to all this stuff. It's not completely intuitive, but neither was Bitcoin when it first came to be. There was a learning curve to that. Any real innovation really requires a little bit of due diligence to understand. And so again, we need to improve our efforts to make that more clear for you guys. So this is like step one of that. Any other feedback you guys can give us as far as like what it is we need to produce to make things more understandable? Yeah, let us know, because we want to make all of that for you guys.
Yeah, absolutely. I appreciate you guys for watching. And if you have any questions on how DMT works, definitely let us know.
If you're a creator interested.
Yeah, if you're a creator.
After watching this, like, dude, I could do that.
Yeah.
Really hit us up.
Yeah, hit us up. Yeah.
Yeah.
And yeah, if you guys know any DMT action happening out there, let us know in the comment section below. Appreciate you guys for watching. We'll catch you in the next video.
Peace.